Hi everyone, today we're going to finish chapter 10.3 and the topic is comparing two means, paired data. This is our third day on this section and our objective is to perform a significance test about a mean difference. So yesterday we constructed a confidence interval about a mean difference, and as you've noticed, the structure goes confidence interval, then significance test. All right, so let's get started here. So we have some conditions for performing a significance test about a mean difference. I know this sounds very redundant, but it's random, 10%, normal, large sample. All right, notice same exact conditions as the confidence interval. Notice up here, when we set up our null hypothesis, we set it up with mu diff equal to some hypothesized value, which is more often than not 0. So when is that mean difference equal to 0? That's basically the null that we're operating against. And the alternative will usually be, is the difference not equal to 0? Is this mean difference greater than 0? Or is it less than 0? So just our typical 3 different alternative hypotheses. Here is our test statistic, and you might be familiar with this because when we did our regular one sample t-test, this is pretty much exactly what it was, with the major difference being us having x bar minus mu over standard deviation of x divided by radical n. Now this mu was the null hypothesis that was assumed, whereas here we're more often than not going to use 0 as we said, and this will be our sample mean difference instead of just a sample mean. So if you go back and look at chapter 9's notes, you'll notice same format of our test statistic, and when we get our p-value, we use that test statistic. And we'll talk about how to do that with and without a calculator as we move on. So we're going to take a look at this study that was done. So I'm going to go ahead and quickly read through it. And it says that researchers designed an experiment to study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Each subject was barred from coffee, colas, and other substances with caffeine for the duration of the experiment. During one 2-day period, subjects took capsules containing their normal caffeine intake. During another 2-day period, they took placebo capsules. The order in which subjects took caffeine and the placebo was randomized. At the end of each 2-day period, a test for depression was given to all 11 subjects. Researchers wanted to know whether being deprived of caffeine would lead to an increase in depression. The table displays data on these subjects' depression test scores. Higher scores show more symptoms of depression. So just quickly scanning through the data. So you had, these are your identifiers. They had a total of 11 subjects. So subject 1, when they had the caffeine intake that was taken via capsule, they reported a lower depression score as opposed to taking the placebo, in which they reported a depression score of 16. Now, how did they come up with these scores? We don't know. We'd have to look at the full research article and the methods and the actual instrument used to obtain these scores. But with the limited knowledge that we have, we can see like a big trend here where the placebo depression scores are much higher, and there's only one subject number 11, who reported a lower depression score when on the placebo, and they would have we'll see that that's the only one that gives a negative difference. All right, so here what you're going to want to do is we're going to want to make a list. Now let's read through the rest of the problem and then I'll tell you what to make a list of. Do the data provide convincing evidence at the alpha equals 0.05 significance level that caffeine withdrawal increases depression scores on average for subjects like the ones in the experiment? All right, so what we want to do is we want to see does the difference in these two scores show that there is an increase when you have no caffeine. So the placebo is not having the caffeine, and obviously caffeine means you do have it. So what we're going to do is we're going to create a third row here with just differences. So that's 11, that's 18, that will be 1, this will be 4, this is 6, and this is 19, this is 6, 3, 13, 1, and then finally -1. So we're going to make a list on our calculator. I know this is a little blurry here, but make a list in your calculator of these differences. And we are going to go with this particular order of placebo minus caffeine group. Okay, and I'll explain why in just a moment. But pause the video, make your list, and we will move on to the next step shortly. Okay, so again, we are looking to see does caffeine withdrawal increase depression scores? So when we set up our state portion, we're going to say mu difference is equal to 0. So that's assuming there's no difference whatsoever. But for the alternative, we're going to say that the mu difference is greater than 0. Okay, because we suspect that having a withdrawal of caffeine does increase depression scores. And the increase is going to be represented by a difference that's greater than 0. Because once we get all these differences, and we take the mean of all these differences, we should see a mean that's higher than 0. So we're going to define mu diff as the true mean difference, placebo minus caffeine. Very important that you make that distinction so we know how to exactly measure this difference here and see if it's actually greater than 0. So placebo minus caffeine and depression test scores for subjects like these. We did not randomly sample from the population. We had some volunteers, so we have to leave this phrase like these. And we have an alpha of 0.05. So for the planned portion, you could say one sample t-test for mu diff, or we could say a paired t-test for mu diff. Researchers randomly assigned the treatments, placebo then caffeine, caffeine then placebo to these volunteers. So that's where the random condition comes in. We made sure to give each subject both treatments, but just had to do it in a different order. The normal large sample condition, we only have 11 pairs of data. So when we make here we have a histogram, but if you were to make a dot plot, you wouldn't notice any outliers, nor would you notice any strong skewness. So it is safe to proceed. All right, so with the, I don't have it here, but with that extra list here with 11 and 18 and 1 and 4 and 6 and so on and so forth. If you made a list and you want to do it, if you want to do it by hand, by hand meaning plugging in values into the test statistic, you'll still have to use technology for a little bit. You have a X bar difference of 7.3. So the mean difference in the scores is about 7. So standard deviation of those differences is about 6.918. And we have 11 differences. So the test statistic would be 7.364 minus 0 divided by the standard deviation of the differences divided by radical n. And we'd have 10 degrees of freedom. So again, I say doing this by hand, but you still have to use TCDF on your calculator. And because this would be a one-sided test with a mean of 0 here, and you'd have your t distribution that looks something like this with 3.53 out here to the right, and you'd have to shade over to the right, you'd get a p-value of 0.0027 by using TCDF, because you're not going to use normal CDF again, because we're using the t distribution and t scores. If you want to bypass that hand calculation and do the t-test on your calculator, you do a paired t-test, that's totally fine. Make sure you have all your data in L1. Make sure to specify, once you're done, your test statistic, which is 3.53, and your p-value, which is 0.00272. And as you can see, that's pretty low, quote unquote, and it's much lower than 0.05. So let's get into the conclusion because we have one more problem here. So in conclusion, the p-value of 0.0027 is less than alpha equals 0.05. Therefore, we reject H0. We do have convincing evidence that caffeine withdrawal increases depression test scores on average for subjects like the ones in this experiment. So definitely we have some statistically significant evidence. All right, one last problem here. So please go ahead and read through this. And yesterday we made a list of these differences in these two versions of the test that we were referring to that Ms. Gallus gave out. So sorry, you may have to retype those in again and pause the video and do that if you need to, but we're going to go ahead and we're going to conduct a test at the alpha equals 0.01 significance level to see if there is a difference in the average test scores between these two versions. So again, make a copy of that list and we'll go through the whole SPDC process in just a moment. All right, so in our state, we have our mu diff equals to 0. Our alternative hypothesis, we were looking for a difference. We're not really sure of the direction, so we're going to say not equal to 0. And again, make sure to define what mu diff means. Mu diff is the true mean difference, version A minus version B, in final exam scores for AP Stat students in this district, and we're using alpha equals 0.01. So for the plan, we're going to use the paired t-test for mu diff, random sample of 20 AP Stat students in the district. These are the same exact conditions as yesterday when we constructed our confidence interval for mu diff. So you'll notice this is pretty much the same exact thing as yesterday, but instead of doing the paired t-test, we did the t-interval for mu diff. Here is the do step. So the sample mean here of 3.2, this would be our X bar diff, which I believe we talked about yesterday, but if not, we did mention it here. It said that X bar diff is 3.2 and standard deviation diff is 3.533. So that would go here, and then the standard deviation goes here. We have a DF of 19, and the p-value would be 0.0068, and you'd have to, because this is a two-sided test, you'd have to draw your test statistic on both sides and shade both sides, just like we did in Chapter 9. And we didn't really do this much in Chapter 10 because we relied heavily on the calculator, but if you are going to use this method, and you want to calculate by hand, you've got these two tails, and that's why we multiply our TCDF calculation here by 2. Now I know it does say 1,000. Got this from our textbook, so we're going to go 999 like we normally do. All right, and again, if you want to bypass that, go to Data, get your L1 list, not equal to, this is a not equal to test here. But the mu difference is 0, so not equal to 0, and you'll notice the same test statistic and the p-value in the same format. It's in scientific notation, so we'll have 3 zeros in front of that 6.8. All right, so in conclusion, because the p-value of 0.00068 is less than alpha equals 0.05, we reject the null hypothesis. We have convincing evidence of some type of a difference in the mean test score between version A and version B of the final exam for AP Stat students in the district. As a side note, the conclusion is consistent with the confidence interval because I mentioned yesterday you don't have 0 in the interval. So it does give some evidence that